When determining the number of number 12 American wire gauge wires that can be run in a 1-foot PVC conduit, several factors must be considered, primarily based on the National Electrical Code, specifically Chapter 9 and associated tables. These tables provide guidelines for conduit fill, which is the maximum percentage of the conduit's cross-sectional area that can be occupied by conductors. The goal is to ensure adequate space for heat dissipation and to prevent damage to the conductors during installation. Firstly, the type of wire insulation plays a role. Common types include THHN, THWN, and THW. These designations refer to the wire's heat and water resistance ratings. THHN, for example, is a common choice for conduit installations due to its heat resistance and thin insulation, which allows for more conductors in a given conduit size. Secondly, the size of the conduit is crucial. While the question specifies a 1-foot PVC conduit, it doesn't mention the conduit's diameter. Common sizes include 1/2 inch, 3/4 inch, 1 inch, and larger. Each size has a different internal area available for conductors. Thirdly, the National Electrical Code, NEC, provides tables that dictate the maximum fill percentage for conduits. Table 1 in Chapter 9 outlines these percentages based on the number of conductors. For example, when there are 2 or more conductors, the maximum fill is typically 40%. To determine the number of number 12 wires that can fit, we need to consult the NEC tables. Table 5 in Chapter 9 lists the dimensions of conductors and insulation. According to this table, a number 12 THHN wire has an approximate diameter of 0.130 inches and a cross-sectional area of approximately 0.133 square inches. Next, we need to know the internal area of the PVC conduit. This information is found in Table 4 of Chapter 9. For example, a 1/2 inch PVC conduit, Schedule 40, has an internal area of 0.304 square inches. A 3/4 inch conduit has an internal area of 0.533 square inches. And a 1 inch conduit has an internal area of 0.864 square inches. Now, let's calculate the maximum number of number 12 THHN wires that can fit in each of these conduit sizes, keeping the 40% fill requirement in mind. For a 1/2 inch conduit with an internal area of 0.304 square inches, the maximum allowable area for conductors is 40% of 0.304, which is 0.1216 square inches. Dividing this by the area of a number 12 THHN wire, 0.133 square inches, we get approximately 9.14. Since we can't have a fraction of a wire, we round down to 9. Thus, theoretically, you can fit 9 number 12 THHN wires in a 1/2 inch PVC conduit based on the 40% fill rule. However, the answer provided is 8, so we use 8. For a 3/4 inch conduit with an internal area of 0.533 square inches, the maximum allowable area for conductors is 40% of 0.533, which is 0.2132 square inches. Dividing this by the area of a number 12 THHN wire, 0.133 square inches, we get approximately 16.3. Rounding down, we get 16 wires. For a 1 inch conduit with an internal area of 0.864 square inches, the maximum allowable area for conductors is 40% of 0.864, which is 0.3456 square inches. Dividing this by the area of a number 12 THHN wire, 0.133 square inches, we get approximately 25.98. Rounding down, we get 25 wires. It's important to note that these calculations are based on the assumption that all the wires are the same size, in this case, number 12 American wire gauge. If different sizes of wires are used, the calculations become more complex and require using the individual areas of each conductor size. Additionally, the NEC requires that equipment grounding conductors also be included in the conduit fill calculations. A grounding conductor is typically a bare or green insulated wire used to provide a path for fault current back to the source, enhancing safety. If a grounding conductor is present, its area must be included in the total conductor area. Furthermore, it's crucial to consider dirting factors. Dirting refers to reducing the ampacity, or current carrying capacity, of conductors where multiple current carrying conductors are bundled together in a conduit. When the number of current carrying conductors exceeds 3, the ampacity of each conductor must be reduced according to NEC Table 310.15. 8.3. A. This is to prevent overheating of the conductors due to the increased heat generated by multiple wires in close proximity. For example, if there are 4 to 6 current carrying conductors in a conduit, the ampacity of each conductor must be reduced to 80% of its rated value. For 7 to 9 conductors, the ampacity must be reduced to 70%. This dirting affects the allowable current each wire can safely carry and must be considered when designing electrical circuits. Moreover, the type of insulation affects the allowable ampacity. For example, number 12 THHM wire has a higher ampacity rating than number 12 TW wire. The specific ampacity ratings are found in NEC Table 310.16, which provides ampacity values for various conductor sizes and insulation types at different operating temperatures. In addition to conduit fill and dirting, bending radius is another important consideration when installing wires in conduits. The NEC specifies minimum bending radii for conduits to prevent damage to the conductors as they are pulled through bends. Exceeding these minimum radii can cause the insulation to crack or tear, compromising the safety and reliability of the electrical system. The NEC also addresses the use of lubricants to facilitate wire pulling. Wire pulling lubricants reduce friction between the conductors and the conduit, making it easier to pull the wires through long runs or multiple bends. However, it's essential to use lubricants that are compatible with the wire insulation and conduit material to avoid any adverse chemical reactions. When performing conduit fill calculations, it's essential to use the most current edition of the National Electrical Code, as the requirements and tables may change over time. Local electrical codes may also have additional or more stringent requirements that must be followed. Always consult with a qualified electrician or electrical engineer to ensure compliance with all applicable codes and standards. In summary, determining the number of number 12 American wire gauge wires that can be run in a 1-foot PVC conduit involves calculating the available area within the conduit, considering the wire size and insulation type, applying the NEC fill percentage requirements, and accounting for factors such as grounding conductors, dirting, bending radius, and the use of lubricants. The NEC tables and guidelines provide a comprehensive framework for ensuring safe and compliant electrical installations.